Hello, so this is my video on the graded homework one for regression analysis. So the first exercise, we went over a foundation of SLR, and the second exercise was more a little bit of an introduction to MLR. And both of these exercises involve data sets that we use to interpret calculations and our models using R. So let's get right into it. Now I will share my screen to briefly explain exercise one here. So I feel like a big part of exercise one was the relationship between score and mother IQ, and then score and read. So here we have score versus mother IQ. We have a low p-value less than 0.05 here, and we have an R-squared value of 0.3263. So this means that the model is statistically significant, or the um, mother IQ explains it has a decent explanatory means and score. And we can this is shown by the graph of the residuals versus fitted here. You see how it's scattered, so we can assume linearity and constant variance along with QQQ residual shows that pretty tight linear fit here. So this could also go with the like normality of errors and whatnot. So go here. Something else I also thought that was pretty significant within exercise one was question 10, where we look at the confidence band versus the prediction band or the prediction interval. So this like confidence band right here, this gray outline shows where we expect the average of the child score to fall given a mother's IQ versus um, this red band right here, whereas where we are expect a single like any child to score based on any given mother's IQ. The difference between is the average and what we expect for the individual kid between confidence and prediction. These are both 95% confidence as well. So, all right, now to go on to exercise two, we'll briefly go over question five, which explains the significance between the explanatory variables and the miles per gallon. So here we have a p-value of one. Oh shoot. All right, well, I'll fix that later, but we have a p-value of less than 0.05 that is statistically significant, which makes the whole model statistically significant. And also here we have the weight out of all the explanatory variables. The weight is the only one that is statistically significant among these variables. And if we move down here, we find that the residual plots violate they slightly violate the the constant variance the linearity and the normality, because here we have a little bit of a curvature as opposed to more of a straight line. This violates the linearity, and we can also see kind of like a slight curve among the scattered data, which violates the constant variance. And if we go to the QQQ residuals, we see it's hard to tell, but there are two outliers right here which kind of affect the normality a little bit. I know it looks pretty good here, but the two outliers here kind of violate that. So, and then if we go to the question seven, which talks about the Shapiro test, we could see that we have a p-value of 0.06, which is um, greater than 0.05. So we fail to reject the null hypothesis, and we say that the residuals here are statistically significant. So I think uh, residuals are normal. I think they're normal. Residuals are normal. I feel like some key insights I gained while doing exercises one and two were mainly like reading plots, like the residual plots, the QQQ plot, or not the QQ, the QQ plots, the correlation coefficient plots. I feel like all those, I feel like I've developed a much better understanding when it comes to looking at the line of like the regression line or like line of best fit and like the scattered data points, all that stuff. Yeah. Also, just better understanding of like significance, statistical significance, R squared, and also learn the Shapiro test, which is pretty useful. I did think that was very helpful and important. So these first few weeks, I feel like I mastered like interpreting SLR models, and especially after like completing this homework assignment, I feel like I've become more fonder in R. Um, you know, I'm very, I'm not that good at coding and new programming languages, but I feel like this one was kind of easy to learn, and I feel like, I didn't have a hard time with it, but I have not mastered it by any means. I also feel like I've had most trouble with the theoretical aspect within this course, especially exercise three. Um, some of the theorems and derivations are still, hard for me to like wrap my head around or master, but I think they weren't too bad, hopefully. And after completing this assignment, I think I deserve an A for my effort, but a B would be understandable if you look at my theoretical, like the theoretical side, it was challenging, especially parts B and C. So that is my video on regression analysis, homework one.